Alright guys, welcome to Math 0106. We are on Lesson 5, Multiplying Fractions. So, the interesting thing about multiplying fractions is you already actually know how to do this. So, let's look at an example. I'm going to make up a number. Let's say I ask you to factor 20 over 24. Now, let's say that you look at this and you're going to say, well, I know 20 is 2 times 10, and I know that 24 is 2 times 12. Okay, so we have this. Well, this is nothing more than saying, I give you a problem that says 2 over 2 times 10 over 12, right? So, multiplying fractions is really just an extension of reducing. And so what would we do here? Well, I think it's pretty obvious. 2 divided by 2 is 1, and then 10 and 12 are both divisible by 2, so this would be 5, and this would be 6, so this leaves me with 5 over 6. By the way, I want to stress here that when I'm doing this, I'm dividing both of these by 2, right? And then the results I'm writing here. Okay. So let's run through these. Actually, what I'd like you to do is, let me see if I can get all this on here. So what I'd like you to do is pause the video now and work through these. And if you get stumped, then watch I'm about to work through all of these. Watch them. And what I really recommend is as you go through, like if you feel like you got the right answer, then you don't have to like listen to me explain. Just skim through the video to that section so you can see what the answers are. So, in any case, let's go through this together. So 5 is the same thing as 5 over 1, so I'm left with 5 over 1 times 3 over 8. By the way, that's a star. I like to make stars for my multiplication because I feel like the dot is hard to see, and then sometimes the dot gets confused for a decimal. So I try to use a star whenever I multiply, or I may just put them in. The other way I like to write this is just put them in parentheses, which implies that you're multiplying. So, with that being said, can I reduce? Well, 5 doesn't go into 8, and 3 does not go into 8, so I can't. So all I'm left to do is multiply across, so that 5 times 3 is 15, 1 times 8 is 8, and so it's 15 over 8. This is an improper fraction. Don't stress over the fact that it's an improper fraction. All you need to do, we'll leave our answers as improper fractions. So typically on the final in the midterm for this course, or the final really, we don't write things as mixed numbers, so don't concern yourself. Though I want to stress that, and again, we're going to do long division later on in the course, so if this is a little confusing, don't stress over it. You could divide this and say, okay, 8 goes into 15 once, and this leaves me with 7, and so because I have 7, 8 doesn't go into 7 evenly, so we'll say 1 and 7/8. And that's how you would convert it into an improper. Into a mixed. So you could do that if you wanted to, but it's fine to leave it as an improper. Okay, so let's look at the next one, number 2. So number 2, we can write this as 4 over 1 times 3 over 4. We notice that the 4's divide out, and we're left with 3 over 1, or it's just simply 3. Okay. Number 3, more of the same. We can rewrite this as 5 over 6 times 12 over 1. We look at the top and the bottom. We see that 6 and 12 can go into each other, so this leaves me with 2 and 1, or they're both divisible by 6, which leaves me with 2 and 1. And so we're left with 5 times 2 is 10, 1 times 1 is 1, or simply 10. Number 4, 4 over 7 times 14 over 1. Again, if it's a number, you can always just put it over 1. 7 goes into 14 2 times, or 14 divided by 7 is 2, and 7 divided by 7 is 1. This leaves me with 8 over 1, or simply 8. And again, if you want to just write 8, that's fine as well. Okay, on to the next one. So on this one, we see that 3 and 5 don't, and 4 and 2, there's nothing that matches up, so we can't really simplify. So we're just going to multiply across. So this is just 15 over 8. And one thing to take note of with 15 over 8 is when I'm looking at 15 over 8, there's a part of me that's like, I don't know about you, I feel like 8 can go into 15. It seems like it almost works, or they're both going to have factors that work. They don't, but there's just something about it that makes you feel like it does. If you look over here and you're confident with how you've reduced this, and you realize that you can't reduce anything further, this is always the most simplified form. You don't have to worry about it. It's going to be. So even on number 6, there's 5 doesn't go into 6 or 11, and 7 doesn't work with 6 or 11. So I know that this is 35 over 66. I don't have to concern myself, can I reduce 35 over 66, right? You don't have to. In fact, if you did, you're like, maybe it works. What would you do? Well, you could write the factors of 35, which would be 5 and 7. You could write the factors of 6, which would be 6 and 11, and you would see that they don't go into each other. So there's nothing more you can do here. Okay. Number 7, I'm a little worried about space here, but again, 2 does not go into 5 or 9, and 4 doesn't go into 9 or 5. So we just multiply. So this is 8 over 45. Number 8, again, it's funny, you can see that they were just doing 4, 5, 6, 7. None of these numbers go in, so it's just 35 over 24. What they're trying to do here is they're trying to show you that you can't just be like, oh, that's 3 and 2. That's why we're seeing these examples. You can only divide out if we're looking at the tops and the bottoms if they match up, not with laterally if the left and the right match up. Okay. In number 7, we're back to cases that do work. We can see that 7 goes into 21 3 times, or 21 divided by 7 is 3, and 7 divided by 7 is 1. And the same thing is true over here, which gives me 8. So this is just 3 over 8. The next one, same thing. 5 and 25 gives me 5. 6 goes into 24, gives me 4. So it's 4 over 5. I'm going to pick up the tempo a little bit, and please, if I need to go into any of these problems in more depth, let me know and I'll slow it down. Here, 8 goes into 32 4 times. 7 goes into 21 3 times. So let me put a 4 here and a 3 here. And one common mistake that people do is they end up putting the 3 on top. Just realize that anytime you have a situation that has where you're putting one into the other one, let me back this up a little bit. So let's look at the 7 and the 21. Technically what we're doing is we're dividing both of these by 7. This is how I like to really think about it so that there's no issue. So 7 divided by 7 is 1, so that there's no issue at the top. And the bottom of 21 divided by 7, which is 3. So the 3 would be on the bottom or the denominator. One of the ways that this is taught is you say, well, 7 goes into 21 3 times. And when you think of it in that term, sometimes people put it on top, but it would always go, if you're putting a smaller number directly into a bigger number, wherever the big number is located is where it's at. So the 3 would go on the bottom. Whereas with 8 and 32, because 32 is the bigger number, the 4 would go with the top. Okay. So I apologize if that was overkill. 12 is where it gets is where I actually enjoy the problem a lot more, because you're seeing more. It's the same thing. So we can say, hey, look, 3 goes into 9 3 times, 5 goes into 10 2 times, and 2 goes into 8 4 times. So I'm left with 3 over 2 times 4, which is 8. This is getting cluttered. Okay, so let me do 13 below. I'm going to erase this. Okay, so we get a little more space here, not so cluttered. 13 is 1 over 4 times 15 over 20 times 6 over 9. So what I'm going to do here is we're going to say, hey, okay, I'm going to look at 15, and it doesn't matter which one you use. You can use any of the bottoms that match up. So some of you may look at 15 and 20 and say, hey, look, both these are divisible by 5. Some of you may look at 15 and 9 and say, hey, they're both divisible by 3. And either way is correct. I'm going to use 5 because I find that is the bigger one makes the number smaller, which makes the problem overall a little easier. So I'm going to rewrite the same thing. You can do it all at once, but in my experience, if this is the first time that you're playing with this, it gets very cluttered. So I'm going to rewrite it as such. Okay. So all I did here, right, is I left the problem the same problem as before, except for the fact that I changed 15 over 20 to 3 over 4. And then we're going to do the same thing with the 6 and 9, right? So 6 and 9 are both divisible by 3. So now I'm going to be left with 1 over 4 times 3 over 4 times, let me do this in yellow, 2 over 3. And we're going to keep at it. So if we can, let's see if we can cancel anything else out. Well, sure, we can see that the 3 and the 3 will divide out. I'm just going to do it like this. 3 and the 3 will divide out. And then the 2 and the 4 will divide out with the 2 on the bottom. So this is going to leave me, when things divide out, you have the 1s on the top, so you're left with 1. 1 because 1 times 1 times 1 is 1. And on the bottom, we're just left with 4 times 2, which is 8. So this would just become 1 over 8. Now, I want to illustrate that if I give you the same problem, you don't want to write that way, 1 over 4 times 15 over 20 over 6 over 9. Once you get comfortable with this, if no one was watching, I would be doing it like this. I'd be, this is 3 and this is 4, because 15 and 20 are divisible by 5. This is going to become 2. This is going to become 3, because 6 and 9 are both divisible by 3. And then I'm going to say the 3 and the 3 divide out. And I don't actually write the 1, but I'll write the 1 to be clear. And then the 2 and the 4 cancel out, and I get 2 and 1. And so I'm left with 1 times 1 times 1, which is 1, and 4 times 2 times 1, which is 8. And that's how I would do it if no one was watching. And as you get comfortable with this, you probably will just naturally gravitate towards that. But if you find that to be confusing, then just go line by line. And as I look at this, it's funny because, right, as you're working through it, hopefully it's clear, but when you look back on it, you're like, oh my god, numbers are all over the place. Okay, cool beans. All right, so we are on 14. So let's take a look at 14. I just put it on a different page because it's getting way too cluttered. 14, let's see here. So again, I'm just going to look at the top. I'm going to say, hey, is there anything that I can divide into anything else? So I see 14. And with 14, we have options, right? So 14 and 16 are both divisible by 2. And 14 and 35 are both divisible by 7. I'm actually going to use 14 and 35. Like I said in the previous problem, I like to go after the bigger ones. So 14 and 35 are both divisible by 7, which would leave me with 2. And I'm actually going to write divided by 7 off to the side, so I can, if I look back on this, I can see what's going on here. So this now is going to leave me with 2 times, I'm going to put a 5 here. Let's see how much I can align everything. 45 times 12. Let me even change that to a green so you can see clearly what the only thing I'm changing. Let's see here. 27 times 16 times 5. And you can see, like, as I rewrote it, I put them all as the same fraction, illustrating what I talked about at the beginning of this section, which is that reducing and multiplying are essentially the same process. Okay, so we're here, and let's see if we can clean up some more. So I'm looking at 45, and I see 27, and both of these are divisible by 9, and that's all that I can work with. So let's do that. Let's divide both of these by 9. And this would leave me with 5. This would leave me with 3. So now I'm going to be left with, let's try to keep this in the same color combination. So 2 times 5 times 12. You see what difficulty I'm going through to show you clearly how to do these problems? I know, I'm so kind. Okay, 3 times 16 times 5. Okay, keeping it color coordinated. All right, And now let's look at the next number. So we're going to look at 12, and you have options. You can go, we can put 12, with 12 we could work with 3, because they're both divisible by 3. Or you could do 12 and 16, and they're both divisible by 4. I'm actually going to go with the first one, because that would mean one less number to concern myself with. So 3 divided by 3 is 1. I'm not going to write the 1 when I rewrite it, because the less I look at, the easier it is for me to process. So this is going to become 2 times 5. Oh, look at me struggling with the color coordination. 2 times 5 times, you know what? I'm going to do this. Let me just put all the green at once. Let me do all the yellow at once. I said I wasn't going to rewrite the 1. Let me not do that anymore. And then I guess it's like it looks almost black, but I think it's a navy blue 5. Okay. All right. You come for the math, you stay for the social commentary on the colors. Okay. Attempts at humor. Let's see here. So from here, this is nice. We can easily see that the 5 and the 5 divide out, and that's 1. I'm actually just going to not even rewrite that. I'm going to leave it as such. And then the 16 and the 4 divide out, and I'm going to be left with 4 here. So I'm going to be left with, I'm not going to write the ones that cancel out. This is going to be 2 over, look at this. The struggle is real with keeping it color-coded. 2 over 4. And at the end, we are done. Yay. We can divide both of these by 2. And I get 1/2. And if you really want me to, I can say divide by 4 here. Divide by 4. Divide by 5. Divide by 5 earlier, so it's 1 and 1. I think it kind of becomes a little excess. Okay, so the answer is 1 over 2. Now, my advice is if you are struggling with seeing how to clearly do this, you want to go line by line like I just did here. But over time, you will get to the point that this is not necessary. You can just do it all at once, and let me show you what that would look like. Okay, so if when I redo this, it seems overwhelming, then just go line by line. But if I was doing this again with nobody watching, I would just go 14 and 35 are both divisible by 7, so this is going to leave me with 2 and 5. Okay, let me rewrite that 5. I wanted to write a 7, and I turned the 7 into a 5, sort of. With 45, and I think I did 45. What did I do? 45 with what? 45 and 27, I said, are both divisible by 9. Okay, so then I would go here, and this is 9, and I'm sorry, I divided both by 9, so that would be not 9, that would be 45 divided by 9 is 5, 27 divided by 9 is 3. There we go. What's interesting is that when I actually looked at this, I was looking at 45 and 5, and I wanted to cancel those out. So I could have done it a different way. Maybe I'll show that afterwards. Then I think we did 3 and 12 becomes 4, and then we did 4 and 16, which becomes 4, and then we said 5 and 5 divide out, and then 2 and 4 leaves me with 2. All of these on the top cancel, so it's 1, so I'm left with 1 over 2. Which I think in a strange way, once you get comfortable, it's actually a little clearer. Okay, let me, I don't know, I'm killing this problem here, but let me do it one more way. Let's do 14 over 27 times 45 over 16 times 12 over 35. And what I want to show you is that, I'm not going to go in excess detail here, but you don't have to pick the combinations that I picked, right? So I could have done, let's do it this way. Let's say 14 and 16 are divisible by 2, so I could have done 2 and 8, and I'm sorry, divide both of these by 2, which would leave me with 7 and 8. Then maybe I go 7 and 35 is 5, and then maybe I go 5 and 45 is 9, and then maybe I go 9 and 12 is 9 and 27 are both divisible by 3. and then maybe I go 3 and 12 is 4, and then maybe I go 4 and 8 leaves me with 2 on the bottom, and so it's 1 over 2. So the order in which you choose is up to you, and you can see that there's a lot of different approaches to these problems. So hopefully that makes sense, and it was worth your time to see me work through that. Okay, let's go back. Okay, so the next two are not so bad. We're going to do 15, which is 32 and 7/8. So 15, 32 times 7/8. And you can see what I'm already trying to do. 32 is 32 over 1, right? And we're just going to cancel. So we say, hey, look, both 32 and 8 are divisible by 8. And this is going to leave me with 4 times 7. And on the bottom, we're just left with, well, really, we're just left with 1, right? Because this is 1. 1 times 1 is 1. So this is just going to give me 28. Not too bad. 16 is going to be 12 over 7 times, look, I said I was going to put stars and I'm putting dots. 7 over 8. And on this one, it's the same thing. We can see, hopefully this is okay. I'm just going to go 7 and 7. They divide out. And this is going to divide by 4. And this is going to divide by 4. So that's going to leave me with what? 3 and 2. Which gives me 3 over 2. And you can see me slowly as we work through this. I'm gravitating more towards the way I like to write it. And I hope that makes it, that's not too confusing. That actually makes it clear why I'm doing that. And hopefully you're slowly gravitating towards that as well. Okay, let's see here. What's the next one? Okay, so we are here we have 17 through 20. And on this worksheet, these are written as word problems. It's really more of the same though. Okay, so area is length times width, and one thing that I think that it's very important in math is not to just memorize formulas, but to understand why things are what they are. So here's a length and here's a width. And the reason why area of a rectangle is length times width is that what I'm doing with the area is if I take this W length and I add it, now technically I have so many lines here that this would end up becoming shaded in, right? But if I add each of these lines, there would be L lines, and that's would give me the inside portion. So let me give you a concrete example. So if I gave you a rectangle and I said that this was a length 5 and this is 2, what we're really doing when we say it's 2 times 5 is I'm cutting it up into rectangles, into 2 rectangles, each with a length of 5. So you're literally taking this, which would have 5, and this would be another 5, and adding it together to get 10. So, also, by the way, I know we're not seeing this yet, but if I wanted to do the area of a triangle, that would be the formula for that. Say I have a triangle like so. The formula is base times height divided by 2. And the reason why that's the case is, notice that if I create a rectangle here, from what we discussed earlier, area is length times width. In this case, length and width are base and height. The length and width are here. Is that how I labeled it? I switched it. Oh, well, let me just finish it off. So let's say this is length and width. So what you can see here is that a triangle is actually half of a rectangle. So if the formula for the rectangle, we're using B and H instead of L and W, is B and H, you're doing half of it, right? So that would be divided by 2. And that's why the area of a triangle is just 1/2 base times height. It's literally what you're doing is you're taking half of a rectangle. Triangle is just half of a rectangle. And I'm stressing this for the sake of this, is that there is no way. So when I teach math, I run through several subjects from from this class to apparently doing stuff in geometry to doing calculus. And there's no way I could hold all this information in my head without understanding it. So a lot of times what I'm doing is I'm thinking to myself, well, where does this come from? And because I understand where it comes from, I can quickly derive the formula. And that is, I feel, is the fundamental key in math, is as long as you really understand where things are and where they come from, you don't have to memorize anything. You just quickly derive it, or you just quickly logically think through, and you realize, oh, this is what it is. That's also how our brains are mapped. We're not designed to have a series of disconnected ideas. Your brain is actually works more as a web, where one thing links to something else. So this is why, we use acronyms of names to help memorize, I don't know, planets, or we say things in math. We say, for example, PEMDAS, right? PEMDAS is a way to memorize order of operations. So parentheses, exponent, multiplication, division, addition, subtraction. This, by the way, is math. Oh, got too close to the. Let me just write sub for subtraction. I don't have a lot of space here. Actually, I'll write it like this. Sub. This, by the way, in this course, I'm giving you a preview here again. This is mathematical grammar with math. That's redundant. This is mathematical grammar. In other words, this tells you the order to which you solve when you have a bunch of problems that, let's say I give you 2 plus 3 times 5. This tells me that I do parentheses first, and then I would multiply. I paired these two because what we'll see later is that multiplication and division are the same operation, and addition and subtraction are the same operation. Okay, so that was a little bit of a tangent, but I think it's worth the time. What are we doing here? We are talking about the area of a rectangle. So we know that that's just length times width. So this is just nothing more than 4 times 3/4. And I'm just going to quickly say, hey, look, the 4 and the 4 divide out. They're both 1s, and so I'm left with 3. Okay. Oh, look at that. 18's a triangle. Guess that talk about triangles was relevant. Area is 1/2 base times height. Notice I wrote 1/2 base times height, and here I wrote it as BH over 2. These are the same thing, and this is a little bit beyond the scope of this class, but you can see, let me put stars here, that B is the same thing as B over 1, H is the same thing as H over 1. So if you multiplied all of this, you would get here. So we can do math with letters, or what we call variables, and you see you get the same thing. So they are equivalent ways of writing. Okay, it's kind of like the idea that dividing by 2 and multiplying by 1/2 mean the same thing. So if I say half of 6, that's 3, and if I say 6 divided by 2, that's 3. It's because they mean the same thing. So here we're going to do 1 over 2 times 10 over 3 times 4. And I'm going to put 4 as 4 over 1. I'm running out of time, so I'm going to quickly go through this. The 2 and the 10, 2 goes into 10 5 times. We're left with 5 times 4, which is 20. 3 times 1 is 3. It is okay to leave it as an improper. Okay, number 19. Let me squeeze number 19 over here. We're taking the area of a garden, which is 6 times 7 over 3. Not in this class, we're not going to do this, but in future classes, pay attention to your units. If the teacher wants to be mean, they will change the units on you to see if you're paying attention to what you're reading. So we have 6 over 1 times 7 over 3. We know that 3 goes into 6 2 times. Leaves me with 2 times 7, which is 14. Okay. Number 20, and I need to hurry. I got about 45 seconds to do this. Number 20, let me put this right here. A lot of words, but real simple. It's just basically saying you have 45 couples. They're doing 2/3 pounds of salmon per couple. So this is just simply 45 times 2/3. We know from a clock, 3:15 minutes is 45. So we're left with 15 times 2, which is 30. So it says how many pounds of salmon? That would be 30 pounds. All right, guys. I'm going to stop here. Next time, we'll talk about dividing fractions. See y'all in the next video.